Metal ions are closely related to daily production and life. Life maintenance, food and water safety cannot be separated from metal ions. Through the inorganic chemistry course, we have studied the identification method of metal ion. Then what is the amount of metal ion in food and water samples? This is one of the problems to be solved in complex matrix titration analysis. The formation of complexes is the most common reaction characteristic of metal ions, such as complexes of chlorophyll, magnesium, and heme ion. How can the complexation characteristics of metal ions be applied to quantitative analysis? Welcome to join me in studying the complex matrix titration analysis. The complex matrix titration and the acid-base titration have similarities, and the main differences lies in the study object and the reaction principle. First of all, we will talk about the basic concepts of complex matrix titration analysis. The analytical method of using the reaction of metal ions and complexing agents to produce stable complexes for the determination of a certain component. That is, the method of volumetric analysis based on the reaction of the following complex is called the complex matrix titration analysis. The common complexing agents include inorganic and organic complexing agents. Inorganic complexing agents are usually unidentate ligands, generating simple or polynuclear complexes. Organic complexing agents are usually multidentate ligands and form complexes called chelates. Is it possible for all complexing agents to be applied in complex matrix titration analysis? We will find it out in the follow-up study. The characteristics of simple complex and chelate are as follows. The simple complex has no ring structure and poor stability, the complexation reaction of which occurs in a stepwise manner. The chelate with ring structure has good stability and a fixed coordination number. No stepwise complexation. Therefore, it is knowing that on the base of the characteristics of two complexes, only multidentate ligand forming chelate with metal ions can be used as complexing agents for complex matrix titration. Typical complexing agents are as follows. The most widely used is ethylenediaminetetraacetic acid, commonly shortened to EDTA. EDTA can accept two protons to form a hexaprotic acid, H6Y2 positive, and all six protons of H6Y2 positive can, so there may be 7 different species in the solution. The distribution fractions of different species vary with the acidity of solution. In the 7 species, the complex formed by Y4 negative and metal ions is the most stable. The following is a structure of a typical complex EDTA forms with metal ions. Reactions of EDTA chelating metal ions have following characteristics. First, EDTA chelates many metal ions rapidly. Second, the complexation ratio is simple, that is 1 to 1. Third, a chelate with multiple 5-membered rings can be formed and the structure is sufficiently stable. Fourth, the color of the complex is closely related to the color of ions themselves. The complex formed by EDTA and colorless metal ions is colorless. A complex formed with colored ions has a darker color. In addition, when EDTA forms complexes with metal ions, protons may be released, thus affecting the acidity of the solution. Through this lesson, we should know well about the requirements of the complexing agent for complex matrix titration analysis, and the characteristics of metal EDTA complex.